Now we came to the third part about one-to-one functions, and here we will give some theorems and results about one-to-one functions. Recall that when we assume that f is one-to-one function, that means for every x belongs to A and for every y belongs to A, if f of x is equal to f of y, that means x is equal to y. And also we have the contraposition, which means that for arbitrary element x in A and y in A, if x is not equal to y, that means f of x is not equal to f of y. This means that different elements have different images. Now we use these properties to prove theorems about one-to-one functions. The first theorem is about composition. If f is a function from A to B is a one-to-one functions, and g, a function from the set B to the set C, is one-to-one function, then the composition of f and g, which give me g circle f, this function here also has the property of being one-to-one function. In the proof, this is an if and then statement, so we'll assume that f and g are one-to-one function, and then I want to prove that g circle f is one-to-one, and g circle f will be a function from A to C, and this means that I will take two elements x and y in A, and I prove and I assume that their image are equal in C, and then use this results, this assumption, to show that x is equal to y. So I will assume that f and g are one-to-one functions. I will take two elements x and y in the set A and assume that their image under g circle f are equal. So g circle f at x is the same as g circle f at y. But by the definition of the composition of function, we will have g f of x is the same as g f of y. Now we came to the condition that g is one-to-one. So the what inside here are equal. The image of f of x and f of y under g are equal. That means f of x is equal to f of y. But now again, f is one-to-one function, and the image of x and y under f are equal. That means x is equal to y. And that means that g circle f is one-to-one because we take x and y in A and we assume their image are equal. We found that these elements have to be also equal. So let's break the steps of the proof by using diagram. So we have three sets A, B, and C, and we have a function here f, which is one-to-one, and a function here g, which is also one-to-one. Now we have another, the composition will be from A to C is g circle f. Now I assume I have two elements x and y, and these two elements will be mapped to g circle f of x, and y will be g circle f of y, and I will assume that these two elements are equal. So these two elements goes to also to under f, it goes to f of x and f of y, and f of x and f of y goes under g to the same values here. Now g is one-to-one. It means what? Since they are equal here, it means that f of x is equal to f of y. And since f also is one-to-one, and these are equal under f, that means x is equal to y. And so in 2 steps, we prove that when these are equal, x have to be equal to y, and so g circle f is one-to-one function. Another theorem. Let f be a function from a set A to the set B, and g is a function from a set B to the set C, if the composition of f and g, which give me this function g circle f, if g circle f is one-to-one function, then the first one, f, is 1 to 1. The proof also is a direct proof. We assume that G circle f is 1 to 1, and G circle f is a function from A to C. I want to find that f is 1 to 1 when f is a function from A to B. Now to prove that f is 1 to 1, I will take two elements in A and try to, and assume their image are equal under f, and try to prove that x is equal to y. So we assume that circle f is 1 to 1 function, and now I want to prove that f is 1 to 1. So suppose x and y in the domain of f, which is A, and the image of x and y are equal. So f of x is equal to f of y. Then we can use x and y in the A, and G circle f also have the same domain A. So if I do G for f of x and G for f of y, since they are equal, their image under G have to be equal. But now G circle f is 1 to 1, which means that since the image for x and y are equal, it means that x is equal to y, and that means f is a 1 to 1 function. Now let's see how to find a counterexample for a statement involving 1 to 1 and composition of functions. So give a counterexample for the following statement. Let f be a function from a set A to a set B, and G is a function from the set B to the set C. If G circle f is 1 to 1, then G is 1 to 1. So here it says that if G circle f, the composition is 1 to 1, then the second function is 1 to 1. This is a wrong statement, and we will give a counterexample on finite functions. So I write this example using a row diagram. So I give a function f and g. Both f and g are 1 to 1 functions because different elements in the domain of f have different image in the codomain, and also for g, different elements in the domain of g have a different elements in the codomain, a different image. And since f and g are 1 to 1, by the previous theorems we know that G circle f will be 1 to 1 function. Now how to change this function g such that the result is still 1 to 1, but g is not 1 to 1. To make that, what I have to do is just add some elements in the domain of g. So for example, I can put here 4, and to make it not 1 to 1, 4 have to have the same image of 1 element in the codomain of g. So I will take 4 to z. Now here g is not 1 to 1. The new g is not 1 to 1. But you see that G circle f still will be the same as before. It is 1 to 1. So by this I give an counterexample where the function G circle f is 1 to 1, but G is not 1 to 1. By this we finish the third part about 1 to 1 functions.